Good day, I'm Ryan Hollis, and together with me is Salamaris Mendoza, and we are taking a Bachelor of Secondary Education major in Mathematics at Western Mindanao State University, Ipo Campus. And as per requirement, in the Logic and Set Theory, we will be discussing about one of the topics under that subject, which is the arithmetic and ordering of natural numbers. So let's get started. So, before we commence our class for today, let us pay respect first to our Creator. So for those who are Catholics, you may now do the sign of the cross in the name of the Father, the Son, and the Holy Spirit. Amen. Dear Lord, Amen. Good morning, everyone. How are you feeling today? That's good to hear. You are all doing well. So, Miss Mamela, can you please check attendance? Who's absent for today? Very good. No one is absent for today. That's what I really like about this section. Moving on. So before we proceed our lesson for today, let us always be reminded on our classroom rules. So for number 1, we should always be maintaining the silence. Okay, so preserve a quiet atmosphere during instructional periods to facilitate undivided attention to the learning material. So always observe silence, especially when I am discussing. Okay? Is it clear? Okay. Next, we have attention and focus. Direct your gaze towards the teacher or relevant instructional materials throughout the lesson to ensure a comprehensive understanding of the content. Okay, for second, we have raise hand protocol. Employ the practice of raising one's hand to seek clarification or contribute to discussion, refraining from spontaneous interaction. So if you have clarifications, questions, or violent interaction, you may raise your hands. Okay, for the third classroom rules, we have respect for personal space. Demonstrate a consideration for the personal space of fellow classmates, fostering a conducive and respectful learning ambience. So always be reminded that respect begets respect. So respect everyone if you want others to respect you. For the next, we have sitting discipline. Remain seated unless expressly granted permission to move, thereby minimizing potential disruptions to the learning process. So as much as possible, you need to sit properly and don't move or don't go out unless you are being permitted. So for the last one, we have responsible handling of materials. Exercise judicious care in the handling of class materials, utilizing them in a manner consistent with instructional expectations. So as much as possible, you need to handle the materials with care. So that's the rules or the classroom rules for our subject for today.
Now, who can remember the topic that we discussed last meeting? Okay, anyone? Okay, Tunggol? Okay. Now, what is transitive set? Okay, anyone? Raise your hand. Okay, RC. Okay, thank you. Now, let us proceed to a short activity or short game. So, it is an activity time. So, it is called Name It to Win It. Okay? I will be presenting some visual cues and you will guess what it is and also give an insight about it. Okay? Okay, proceed. Okay, sorry. So, I will be presenting. Okay? So, this one. What is this? Anyone? Okay, I will call Justin. Okay, Justin, can you guess what it is? Okay, thank you. Okay. Now sit down. Thank you very much. So this is a natural numbers. Very good. Clap your hands, please. Okay, thank you. Now, who wants to raise your hand to answer this activity? This one. Okay, anyone? Okay, I will want to let us stand. Stand, please, Ryan. Okay, Ryan. What is this? Okay. Let's see. This is an arithmetic. Very good. Clap your hands, please. Clap your hands. Okay. Now, class, we have an activity for this morning. Okay. So let me group you into 5. Let us do a head counting from here. Okay? What is the last number? 4. Okay. Now, go to your respective groups and clockwise if you are all settled. Okay? Are you all now ready? Okay. I have here an incentive eggs. Each egg has a different points. Each egg. So this egg, this white egg is 5 points. The purple egg is 5 points. The green egg is 4 points. The blue egg is 3 points. The pink egg is 2 points. And lastly, the yellow egg is 1 point. Okay? So, these incentive eggs will be utilized in your scores in my activity. And also, these also will be utilized during with your behaviors during my discussions. So, please behave. Okay? Okay, I have strategically placed 5 pieces of paper in our classroom. So your goal is to find it, solve it within 2 minutes, okay? And also, you need to present and articulate, solve for it, and articulate and present your solving papers in the class, okay? Okay, this is the direction that you had earlier with our activity, right? So this is the direction. Identify whether the statement is natural numbers or not. Raise the paper labeled natural numbers if the statement corresponds to a natural number. Conversely, raise the portion marked non-natural numbers if the statement does not represent a natural number. So number 1. The number represents the count of apples in the basket. What's your answer in this one? For this one, it is a natural number because starting from 1 when counting, we are starting from 1, right? For the apples in the basket. And the number 2, the number represents the temperature on a cold winter day. Okay, the answer is okay, not a natural number because as temperatures can be negative. Okay, next, number 3. The number represents the position of a runner in a race. So, what's your answer? Okay, let's see. The answer for this is natural number. For example, 3rd place, 1st place, 2nd place. Okay, now for the arithmetic. So, this is the instruction. Identify whether the statement is arithmetic or not. So, raise the paper labeled arithmetic if the statement corresponds to arithmetic, okay? And conversely, raise the portion marked non-arithmetic if the statement does not represent the arithmetic. So, let's proceed. Number 4. The task involves identifying the largest number in a set. So, what is your answer for this? Okay, let's see. It is not arithmetic, okay? Because this is more about ordering numbers, okay? Proceed. Let us proceed. So, number 5. The process involving finding the sum of 2 numbers. What is your answer? Guess it, okay? Okay. Let's see. It is an arithmetic because, example, 3 plus 8 is equal to 11. 2 plus 3 is equal to 5. Okay. Guys, go back to your seats. Remember the rules, okay? Okay, now that you're all settled, let us have the grades of your activity. So, the group 5 got the 5 points, okay? Got the 5 points. Got the green one. Now, group 1 got the 4 points. Okay, clap your hands, please. Got the yellow one. And group 3 got the 5 points. Okay, clap your hands, please. Group 2 got the 4 points also. Okay. Now, the group 4 got also the 5. Okay, clap your hands, please. Okay, now, I have some questions for you. So, how do you feel about the activity? Okay, Mandalo? Okay, thank you for your answer. How about, how did you come up with your answers? Okay, Roy? Thank you, Roy. Now, how did you, what are your considerations of answering your activity? Okay, girl at the back. Okay, thank you for your answers. You got your answers correct. Now, settle down and let us proceed to our topic for this morning. Now that you are ready for our discussion, so I want to ask you, are you familiar with arithmetic and ordering of natural numbers? Okay, no? But then, are you familiar with arithmetic? Are you familiar with natural numbers? Okay. Can you give me an example of it? I want to hear from Kudo. Okay, what is your answer? Can you give me an example of it? Arithmetic and natural number. Okay. So now that you have a prior knowledge about it, so let us dig deeper of our topic for this morning. So our topic for today is arithmetic of natural numbers. But then I will introduce the objectives for today. Okay? So the objectives for today is objectives. At the end of the lesson, the students are expected to read all. Can you read anyone? Let's hear from Adawan. Number 1. Okay. The action that holds for that. Okay. Can you sit down? Number 2. Let's hear from Pamela. Okay. Now, number 3. I will read it. So, create the problem using the commutative, associative, induction, and contradiction properties. Okay? Now, our topic for today is arithmetic of natural numbers. So, preposition. The recursion theorem, let A be a step. A, small letter A, is an element of big A. And the function, and A to the element of A. There exists a unique function h with the omega to A such that h0 is equals to A and h with the quantity of the successor of n with equals to the function of h and n. Okay? So next. So the intuition. So since we're talking about the arithmetic, so this also follows the arithmetic sequence. The sequence of it. So okay, from h0 is equals to a. Okay? The next h1, the quantity niya is 1. And then is equals to the function, which is we copy this one also with the parenthesis, open close parenthesis. Then h0 it equals to f, the function of a. We copy up. We just need to copy the small letter a. Okay. Then next, then h2 with the quantity of 2 is equals to the function of h. We will copy this one here and equals to this one. Another function of f and a. Okay. Yes. The next one. H with the quantity of 3 and the function, we will copy this one. We will copy this one. F here. And since it is the third time with the function, so we will put an exponent of it, which is the function of 3 and a, the small letter a. Okay? Next, when using hm is equals to fa, the function of a. This is to prove this one. Okay? So, the table of h is completely determined. But notice that the function can be any function from a to a, and a can be any set, even the omega or the natural number. So, we can set up the addition by writing the formulas of the form h0 is equals to a, and h with the quantity of the successor n is equals to the function of the quantity of h and quantity of n with the quantity of n. So let a sub 2 be a function. So 2 omega to omega. So we need to select an a and a function. So a sub 2 is equals to 0 is equals to 2 because it is the form of addition. So kapag addition, so you need to add them, right? So 2 plus 0 is equals to 2. So next, a sub 2 with the n, with the successor of n will using this one. So it's equals to a sub 2 with the quantity of n, with the successor of the quantity of a sub 2 and n. Next. So the action of addition, or the plus sign, is a function with the omega to omega. It is the successor as we're used to a sub 2 to 0. So if we add them together, it's equals to 2. Okay, 2, this one is the same with the last slide kanina. So let's build the table for a sub 2. So a sub 2, kapag ang value niya ay, if here is ang value niya is 0, is equals to 2. Kasi 2 plus 0 is equals to 2. So here, kapag ang value niya is 1, 2 plus 1 is equals to 3. But then let us see the process. So, a sub 2 and 1. So, is equals to, copy mo to. Copy, a sub 2 plus 0. So, the successor of the quantity of a sub 2 and 0. So, if we add yan, magiging 2. But then, add 1 because it has the successor sign. So, 3. So, here naman, a sub 2 of 2. Then, 2 plus 2 is equals to 4. But then, let's see again the process. So, again, copy this one. Then, with the successor sign. So, it's equals to 3 because 2 plus 1 is 3. But then, it has the successor. So, it is the additional of 1. Then, it is equals to 4. So, then again, the process will still the same. So, next one. So we have set of adding 2. How about adding m? So a sub m is equals to 0 is equals to m because m plus 0 is equals to m. Okay. So a sub m is equals to the successor of n. I mean times the successor of n. So it's equals to a sub m. Copy this one with the n and the successor.
You go.
So we have set up adding 2. So how about adding m? So a sub n is equals to 0 is equals to m because m plus 0 is equals to m. Okay? Did you get it? So a sub m with the n successor is equals to a sub m with the n of the successor of a sub m of n. Okay? So then build the table for a sub m. So this is the table na niya. Ito na po yung table. So with the follow the formula, a sub m plus 0 is equals to m. So what if ang value nito is 1? So let's see. A sub m is 1. And then the value is 1. So if we add it together, is equals to copy this one with the successor to the outside, the successor of a sub m of 0. So equals to add the successor of m. So continue again the process. A sub m, then the value is 2. So again the process with the a sub m with the 1, copy this one, and then is equals to the successor, the 2 successor of m. Then again, if 3 here, magiging 3 na din yung successor niya, yung last sign sa taas. Okay, next. So let's revert to the comfortable notation using the plus sign. So definition, plus is a function of omega times omega to omega. You get it? So it is a list of ordered pairs such that plus is equals to the quantity of m and n and the p, such that the m and n is an element of omega and p is equals to the a sub m of n. Okay. Yes. Then from this statement, like 2 plus 1 are interpreted functionally. So, plus, again, the sign of this is nasa labas siya. So, plus, pwede siyang ganito and then pwede siyang ganito. So, plus, the quantity 2 and 3 is equals to a sub 2. Then, this is the m, and this is the n. This is the m and this is the n. So, 2 and 3, you will write like this, pwede siya ganito and pwede siya ganito. Since we are using this formula, so 2 and 3, m and n, so is equals to a sub m, diba? A sub m and n. So, ang m niya is 2 and the n is 3, so it is equal to 5. Because 2 plus 3 is equals to 5. Okay, because we are in the addition property nito. So, we will write last mn as m plus n. Okay, pwede ganito, but then we will use this one. Okay, yes? So, next one. So, taking the A as definitional, the following becomes theorem. So, may dalawang theorems na siya, which is the number 1, m plus 0 is equals to m. So, m plus the successor of n is equals to m plus with the successor of n. So, the expected properties of addition can be proven by the cumulative property, which is the m plus n is equals to n plus m. With the number 2 is the associative property, which means that the quantity of m plus n plus p is equals to m plus the quantity of n plus p. So, let's prove it. With the theorems, the quantity for all the element of m sub m is an element of omega. Because 0 plus m is equals to m. If ever 0 plus m is equals to m. So, example. This is m and n right here. So, a sub 0, if ang value nito is 0, is equals to 0, right? So, 0, if yung m is 0, and then the n is 1, it is still considered as 1 because it is the addition. And then, 0 plus 2 is equals to 2, and then 0 plus m is equals to m. Still the same. Next one. Proof by induction. With this induction, the quantity of n such that n is an element of omega and 0 plus n is equals to n. So it's obvious that 0 is an element of t. Suppose that k is an element of t. So, this one. 0 plus k with the successor of k is equals to k the successor of k, because 0 plus k successor is equals to k successor of k. So with the quantity of 0 plus k, the successor of 0 plus k is equals to the successor of k. And then k, the successor of k is equals to the successor of k, which means it is also equivalent. So it is obvious that therefore the k is an element of t, with the successor of k is an element of t, and t is an element of omega. Next, the theorems of or arbitrary. N is an element of omega. So for all n is an element of omega. The successor of m plus n is equals to the successor of and the quantity of n plus m. So equivalently, m plus 1 plus n is equals to m plus n plus 1. So, there is no changes. So, equivalent lang siya, balance. So, proof by induction, t is equals to the quantity of n such that n is an element of omega, and m, the successor of m plus n is equals to n plus n plus. So first, show that 0 is an element of t. So the successor of m plus 0 is equals to m plus 0. So m plus is equals to m plus. So next, show that k is an element of t, which implies that k, the successor of k is an element of t. So the successor of m plus the successor of n, k is equals to the successor of m plus k. So, let's prove it. So, dapat siya equal. So, kung dito, equal, then here is equal. So, m plus the successor of m, I know, the successor of m plus k is equals to the successor of m plus k. So, since k is an element of t, so m, the successor of m plus k is equals to the 2 successor of m plus k. So therefore, t is equal to omega. The same method for setting up multiplication. So kanina, we are talking about the addition, but right now we proceed to the multiplication. So let the m sub m be a functions, be collections of multiplication function omega to omega, and the addition with its usual meaning. So yeah, the successor of with the successor sign. So a sub m of 0 is equal to 0 because it is a multiplication. So m sub m times the successor of n is equals to the function of m sub m to n with the n. Next one. What should the function or the f be? So m sub m equals to 0, still the same. Yeah, still the same with the last slide. So we have defined addition between two numbers, so this makes sense. So next, let's calculate with it. M sub 3. This is sub 3. So with m sub 3 times 0, 3 times 0 is equals to 0, right? Okay. Next, with the m sub m, with the value of the successor of n is equals to m sub 3 with the n plus 3. So m sub 3 with 0 is equal to 0, right? Plus 3 times 0 is equal to 0. Pag 1 naman, so if ever ang value here is 0, what if ang value niya is 1? So still copy m sub 3 of 0, then add the 3 because, wait lang, 3 times 1 is equal to 3, so plus 3 is equal to 0, because 3 times 0 is equal to 0, so plus 3, copy the 3 is equal to 3. Yes? So what if ang value niya is 2? So 3 times 2 is equals to 6, right? But then let's see the process niya. So m sub 3, 2, then copy this 1, another m sub 3, and 1, the value is 1, plus 3, because 3 is the m. So it's equals to 3 plus 3, because 3 times 1 is 3, and then copy the 3, 3 here is equals to 6. Okay? With the next one, 3 times 3, 9. Still the same process. The same regular process niya, but then, yeah, same process. Same right answers. So, next one. Having dealt with the m sub m functions, let's revert to the comfortable notation, this one. This is the sign for multiplication. Okay? So, the quantity of m, of n, and then times the p. So, such that m and n is an element of omega, and p is equals to m times n. Okay? So, we now have the theorem. So, last time we have, earlier we discussed also the two theorems of addition. But right now, we also tackling the two theorems of the multiplication. So, these are m times 0 is equals to 0. Okay. M times the successor of n is equals to m times n plus m. Okay? Next, let's now prove that if m times n is equals to 0, then m is equals to 0 and n is equals to 0. With the theorem m and n, such that with the element of omega, m times n is equal to 0, which implies that m is equal to 0 or n is equal to 0. So we will contradict that the n is not equal to 0 and also the m is not equal to 0. So suppose that m times n is equal to 0 and m is not equal to 0 and n is not unequal to 0. So then m is equals to the successor of a and n is equals to the successor of b. For some, a and b is an element of omega. The successor of a times the successor of b is equal to 0. Then the successor of a times the successor of b plus the successor of a is equal to 0. So, the quantity of the successor of a times the successor of b plus a is equal to 0. That is the contradiction of this. So, the m is not equal to 0 and n is not equal to 0. So that is true. Therefore, m is equal to is true now. So therefore, m is equal to 0 or n is equal to 0. Next, we now have the tools to prove the theorems of common arithmetic. So example, cumulative arithmetic, associative, distributive, or other identities. But then we can continue in this manner to define exponentiation. So let D, E sub m functions denote exponentiation. So A sub m is equal to 0 is equal to 1. So m and 0 is equal to 1. So A sub m to the n, so is equal to m times E sub m times n. Next. So notice the symmetry with the formula A sub m sub n with this successor of n is equals to the successor of m plus m with the d sub m of n. So using this symmetry, one can continue beyond exponentiation. So it is called hyperoperators. Next. So that is the end of the arithmetic, and then let us proceed to the ordering of natural numbers.
So, since we are done discussing about the arithmetic of natural numbers, now let's proceed to the other topic, which is the ordering of natural numbers. You know what? It is very interesting because we will be able to order numbers in a very natural way. So now, shall we proceed? Okay. So in fact, the definition of omega allows us to speak of order. Example, say things like 2 is less than 3. As you can observe when we are counting numbers, it is really evident that 2 is really less than 3 because we say first, or we count the 2 first, the number 2 first, then after that the number 3. So on the table given, we have 0 is equivalent to the empty set. So it is also evident that we can also do that in the next number. So we have 1, 2, and 3. So as you can see in our table, the 3 is that it is equivalent to the number below it. So 0, 1, 2. Okay. Understand? Okay, next. So notice that each set contains all the numbers less than it. So like for example, 2 is an element of 3 and 1 is an element of 3. So we can say that 2 is an element of 3 because 3 is equivalent to 0, 1, 2, and 3. And under the 3, we can see that 2 is really an element of 3. Oh no, this is not 3. This is only just 0, 1, 2. Understand? Likewise, with 1 is an element of 3 because we can see an element of 1 on the set of 3. Understand? Okay, shall we proceed? Okay, good. Next, we have a definition which is the symbol less than, in which the symbol less than is a binary relation on the omega times omega, which is less than is equivalent to the quantity of m and n, in which m and n is an element of omega times omega and m is an element of n. Okay, that's only the definition. So among the members of the set less than would be 2, 3, 4, 10, but not 5, 2. You always have to be knowledgeable about this because the 2 is equivalent to m. 2 is m and 3 is n. Likewise, 4 is m and is 10, but not 5, 2. Why? Because we can say that 2 is less than 3, in which the right representation of that is that m is less than n. So, or m is the quantity of m and n. So, 2 is less than 3, 4 is less than 10, but not 5 less than 2. It is not correct. Understand? So we can always write the less number in the right side or in the element of m. So we can also write it visually. So for the visual representation of this, we can clearly say it because in our as you can observe in our Cartesian plane, for example, this is a Cartesian plane. So we have 0 here, 1, 2, and 3. We also have 1, 2, and 3. So, like for example, we can plot it diagonally, so 2 and 3. As you can see, our x or our m is equivalent to 1. Then, our n is equivalent to 2. Next, we have an equivalent of 2, which is our m, and our n is equivalent to 3. So that is the right proof that m is really less than n, or 1 is really less than 2, or 2 is really less than 3. So now let's proceed. So when we write 2 less than 3, we can also write it this way, or an element of less than, just as we might write x or y. So we can also interchange 2 is less than 3 with 2 as an element of 3. So it's just exact the same, because if 2 is less than 3, then we can also say that 2 is an element of 3. Understand? Okay. Next. So, actually guys, the less than symbol has some properties as a relation. For example, for transitivity. Like for example, we have discussed it in our previous lesson. So, A is less than B and B is less than C. Therefore, or it implies that A is less than C. So, like for example, if 1 is, let's say that our A is equivalent to 1, our B is equivalent to 2, and our C is equivalent to 3. So, by proving it in transitivity or intransitive property, we can say that A is less than B. Therefore, 1 is less than 2, and 2 is less than 3. So, if we can imply that, or we can conclude that in 1 less than 3. So, that is the transitive property of less than. So next, we also have another property, which is a trichotomy. So for example, only one of the following three proportions is true. So only one of this proportion is true. It cannot be two of them, and it cannot be three of them. So we have A less than B, or B is less than A, or A is equivalent to B. So let's give it an example. For example, let's say that A is equivalent to 1 and B is equivalent to 2. So, let's say A is less than B. A is less than B. So, we have 1 is less than 2. Next, we have B is less than A. So, 2 is less than 1 and A is equivalent to B. 1 is equivalent to 2. Which of these proportion is correct? As you can see, only the first proportion, or A is less than B, is correct, because 1 is really less than 2, but not 2 less than 1, and also not 1 is equivalent to 2. So the trichotomy properties says that only one of these following proportion is correct, but not all the time that A is less than B is correct, because there are some instances that B is less than A, or A is less than B is the correct, and the two of them is wrong. Understand? Okay, now let's proceed. Shall we proceed? Okay, we proceed. Next, we have the property 1. So, the property 1 says that it is easy to prove for less than from transitivity. So, A is an element of B and B is an element of C implies that A is an element of C. So, we have the theorem, A is an element of B if and only if A plus an element, the successor of A is an element of the successor of B. So, we need to prove that. So, A is an element, the successor of A is an element of the successor of B implies that the successor of A is an element of B, union of B implies that the successor of A is an element of B, or the successor of A rather is equivalent to B. Proceed? Okay. So, let's suppose that the successor of A is an element of B. We know that A is an element of the successor of A. Why? Let's say, for example, we have an A. Our A is 2. Let's say 2. And the successor is what? So, for us to determine the successor, we need to copy. We need to unite the A and the what's that? We need to copy the A union to the successor of A plus. So A is 2, the union of 2. So to determine the successor, we need to copy this. So we have 2 is what is the union? 2. So we can imply that A is really an element of the successor of A plus. Now, therefore, A is an element of B. So suppose that the successor of A equals B. Again, A is an element of successor of A. Therefore, A is an element of B. Proved by induction. So we have A is equivalent to N such that M, in which N is an element of omega, and for all AM, for all M is an element of N, then it implies that M plus the successor of M is an element of the successor of N. So the question now is 0 is an element of A? Now we will be determining it. So since there are no M in an element of 0, the inference M is an element of 0 implies that M plus an element 1 is vacuously true. So 0 is an element of A. So let's show that K is an element of A. So it implies that show that K is an element of A implies that the successor of K is an element of A. So M is an element of the successor of K implies that M is an element of A, or M is equivalent to K. So we have cases. So for the case 1, we have M is an element of K implies that the successor of M rather is an element of the successor of K, and K plus an element of A, the successor of K implies that the successor of N is an element of the successor of K. So for our case 2, we have M is equivalent to K, implies that the successor of N is equivalent to the successor of K, and K, the successor of K is an element of the successor of K, implies that M, the successor of M is an element of the successor of K. As you have observed in these cases, there is only one difference, which is in the case 1, it implies the element, while in the case 2, it implies the equivalent. Understand? Okay, next. So the last theorem allows us to say the succession preserves order. For example, 1 is less than 2. So even only if 2 is less than 3, implies that 3 is less than 4. So diba, I have already shown to you that this theorem earlier. So next. So we can also prove that no number is less than itself. Right? So for example, we have 2 less than 2. Is that even possible? No. So therefore, we can also prove that no number is less than itself. So trichotomy law for omega, for all natural numbers m, n, it is always true that m is less than n, or n is less than m, or n is equivalent to m. First, observe that only one of these three conditions can be true at a time. So that is what the trichotomy law say to us. So next, we have proof by induction. So A is equivalent to n such that for all m, n is an element of the omega, and m is an element of n, or n is an element of m, or n is equivalent to m. Does this sound familiar to you? So that is A, trichotomy law. So show that 0 is an element of A. So we must show that either m is an element of 0, or 0 is an element of m, or m is equal to 0 for all m's. We will induct on m. It is clear that 0 is equivalent to 0, right? And now we must show that m is an element of 0, or 0 is an element of m, or m is equivalent to 0. So it implies that the successor of m is an element of 0, or 0 is an element or the successor or element of the successor of m. So or the successor of m is equivalent to 0. So 0 is an element of m, or m is equivalent to 0 implies that 0 is an element of the successor of m. Understand? Okay, proceed. So if 0 is an element of m, then 1 is an element of m. We know that 0 is an element of 1. Why? Because 1 is equivalent to 0. As what I have said earlier, that the less than symbol represents to us that the number in the number of the set really really shows us that that it is really less than of it. So, by transitivity, 0 is an element of the successor of m. So, if m is equivalent to 0, we know that m plus the successor of m is equivalent to 1. And since 0 is equivalent to 1, therefore, 0 is an element of the successor of m. So therefore, 0 is an element of A. So now let's prove it by induction. So A is equivalent to n such that for all n is an element of omega, and m is an element of n, or n is an element of m, or n is equivalent to m. So now let's show that k is an element of A implies that the successor of k is an element of A. So we have three cases here. So for the case 1, let's suppose that m is an element of k, then the successor of m is an element of k. And since m is an element of m, we have m is an element of the successor of k. And therefore, k is an element of a. So for our case 2, we have, let's suppose that k is an element of m. So it is true that either the successor of k is an element of m or the successor of k. So it's equivalent to m exercise. And therefore, k, the successor of k is an element of a. For our last case, let's suppose that k is equivalent to m. So we also know that k is an element of the successor of k. So m is an element of the successor of k. And therefore, the successor of k is an element of a. So therefore, the trichotomy law holds on the what? Omega. Very good. Now let's proceed to the well-ordering of tungsten. Oh, I'm so sorry. Well-ordering of omega. So any non-empty subset A of omega has a least element. For example, there is some m such that for all n is an element of A, m is less than n, or m is equivalent to n. So proof by induction. Let's suppose we have some subset of the omega without a least element. We want to show that A is equivalent to the null set. So we will force A to be empty by showing the following set is equal to omega. Now, in the case where n is equivalent to k, if n were in A, it would now be a least element since we are ruled out the case that something in A less than k. So therefore, everything less than k is not in A, and the successor of k is an element of B. So that concludes our lesson for today. So we are down to our topic, which is arithmetic and the ordering of the natural numbers. Now let's proceed to activity time. Now, let me read to you the instructions. So in this activity, you will encounter 5 distinct stations. So each focusing on a unique question with precisely 2 minutes allocated to each station. So your exploration of the assigned question will be both focused and efficient. So at the end of the 2-minute interval, a bell will signal the transition. Since we don't have a bell, I will just say go. Okay, listen. Okay, so prompting you to move seamlessly to the next station. After the moving quiz, all of you will explain your answer to the class, and rubrics will be provided. So I have here 5 different problems. So all you need to do is just to move when I say go. Okay. So group 1 will go to the station 1, group 2 will go to the station 2, and so on. Okay? Okay, are you now ready? Very good. So since you are all ready now, you may now go to your respective stations. Okay, starts now. Stop. The time is up. Group 1, are you ready? So you may now present your answer. So, before we conclude our class discussion for today, let me count your points. So, before that, since you are very behaved today, I don't know what you ate, but you're really behaved. So, I'll give you 5 points each. Let's clap our hands for behave. So, we have the purple, 5 points, 5 points. 5 points. 5 points and 5 points. So, total for group 1 we have 10 points. Group 2 we have 8 points. Group 3 we have 10 points. Group 4 we have 8 points. Group 5 we have 10 points. Let's clap our hands. Okay, so since we are done the discussion about the arithmetic and ordering of natural numbers, now I'll be checking on what have you learned. So the first question is, what does the symbol plus stand for? raise your hand. Okay, Miss Limusnaro. Very good. Okay, for the next question, what are the expected properties of addition that we can use for proving? Okay, Mr. Mandalo. Very good. You really did so well. Okay, for the third question, what does the symbol less than represent in the ordinary natural numbers? Okay, go ahead, Miss Sakura. Nice one. You really got it right. And for the last question, the symbol less than has some nice properties. And what are those? Okay, Mr. Quijano. Very good. So for our evaluation, if you have really gained something in this lesson for today, I have prepared a 3 sets of questions in which part 1 and part 2 is individual activity, while the part 3 is by group. So for the part 1, I will give, please hand this over to your classmate and send it individually. Okay. And in that paper, you can see the instruction of the part 1 and the part 2 as well as in the part 3. But in the part 3, as I said earlier, you will work it by group. So I will only give you 15 minutes to finish the part 1 and part 2 so that we can proceed to the part 3. So for the part 3, now you may go to your respective groups. So the time is up. Group 1, you may now proceed to represent your output. Okay, since we are all done, I want you to please rise and please, John Rose, you may now lead the prayer. Dear Father, Son, and Holy Spirit, dear Lord, Amen.
There you have it, class. Now, goodbye, class. Okay.
Thank you.
Thank you. Bye.